Lowest common multiple. So the first thing is every number has a multiple. Every number has a multiple. So we can start and say 2, multiples of 2, multiples of 3, multiples of 5, multiples of 7, multiples of 9. Let's use multiples of 9. Multiples of 2 now is 2 times 1, which is 2. 2 times 2, which is 4. 2 times 3, which is 6. 2 times 4, which is 8. 2 times 5, which is 10. 2 times 6, which is 12. 2 times 7, which is 14. 2 times 8, which is 16. 2 times 9, which is 18. 2 times 10, which is 20. So we can have multiples of 2. We can start from 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. 2 times 7, 14. 2 times 6, 18. 2 times 9, 18. And 2 times 10, 20. Now, we can also do the same for 3. We can also do the same for 3, where we have 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. Now this is for 3. We can do same for 5, where we have 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. 5 times 7, 35. 5 times 8, 40. For 7, we have 7, 14, 21, 28, 35, 42, 49, and so on. 9, we have 9, we have 18, we have 21, 27, 36, 45, and so on. Now, that's that for multiples. So multiples can be said to be when you multiply a number by a particular integer to get another number. So we can multiply 2 by 1. We can multiply 2 by 2. These are multiples of 2. So different values that we can get from 2 when it's multiplied by a number or an integer. That's the first thing. So that's what occurs when we analyze multiples. Now, the topic is lowest common multiple. Lowest common multiple. And now, what does it mean? Let's take it bit by bit. We have common multiple. And I said multiples are numbers. When we multiply a number by an integer, we form multiples. Now, when we say common multiples, that means we have found the multiples of 2. We have found the multiples of 3. We now check if the multiples are similar. Maybe, for example, we now see 4. We now check here, we see 4. We see 4. That means they are similar. They are together. They are the same. Now, if the multiples are the same, they are known as common multiples. Are you following? So, for example, we have 4 and 8 now. And in 4, we have 4 times 2. It's okay, let's say 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. And we have 8. We have 8. We have 16. We have 24. We have 32. Now, these are the multiples of 4 and 8. The next step is to check common multiples. Now, for this, one of the common multiples we have here is 8 and 8. Apart from that, we have 16 and 16. They are both common. So we can call them common multiples of 4 and 8. But the next step now, which we will analyze, is what do we mean by lowest common multiple? Now, lowest common multiple means, yes, you have checked the multiples. If they ask you now, what are the multiples of 4 and 8? You have 8, you have 16. That's normal. But when you are not told what is the lowest common multiple, that means you will check the multiple. Which one is lower? Between 8 and 16, which one is lower? That is where lowest common multiple now comes in. So meaning that the lowest common multiple is 8. Because between 8 and 16, the lowest is 8. That is lowest common multiple. And I remember I told you that there are so many ways we can find lowest common multiple. There are so many ways we can find lowest common multiple. And I told you about a lot of them, if you can still remember. We have the multiples method. We have multiples method, which we just did. We have the multiples method. We have the prime factor method. We have another one, which is the index method. So we have the multiples method. We have the prime factor method. We have the index method. We have the multiples method. We have the prime factor method. We have the index method. So these are some of the methods that we use to find the LCM, and there are still others. There's one particular one which I believe you all already know about, which I don't need to explain so much. So for example, you are looking for the LCM. The LCM. You are finding the LCM of 12 and 24. This is the normal method which you already know. So all you just have to do is write 2 here. 2 into 12 is 6. 2 into 24 is 12. 2 into 6 is 3. Then 2 into 12 is what? 6. 2 into 3 cannot go, but 2 into 6 is 3. So the next one is 3. 3 into 3, 1. 3 into 3 is 1. So meaning that the LCM is equal to 2 times 2 times 2 times 3. And what is 2 times 2? 4. 4 times 2, 8. 8 times 3 is 24. 24. And this method is known as the grid method. I decided to make this a form of secret. So we have the multiples method, the prime factor method, the index method, and the grid method. These methods are very good, very simple to understand. So, but the first one, which we just analyzed, is known as the grid method. So in the grid method, every division must end at 1, 1. Every division must end at 1, 1. So if it does not end at 1, 1, and you can still divide, you have to divide till it gets to 1. That's for the LCM of 12 and 24. So for this same LCM of 12 and 24, we're also going to handle it using another method, which we have the multiples method. So we have 12 and we have 24. So now for 12 and 24, we are going to break it down. For 12, we have 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. 12 times 5, 60. Now for 24, we have 24 times 1, 24. 24 times 2, 48. 48. 24 times 3, 72. So we are going to check. We have this here and we have this here. We have this here, 24, 24. Here we have 48. We have 48. Now we are going to ask ourselves, these are the common factors, common multiples. Now the common multiples of 12 and 24 is 24 and 48. But now this comes to the last part where I said lowest common multiple means that we have to focus our attention on the lowest common multiple. So what's the lowest here? 24. So this implies that using the multiples method, all we just have to do is to look for the lowest common multiple. After finding the common multiple, we'll come and select which one is the lowest. And what's the lowest between 24 and 48? 24. So 24 serves as the lowest common multiple. All you just have to do under the multiples method, you have to ensure that you select the one that is the lowest. It's that lowest that will be your final answer. You understand? That lowest will serve as your final answer. But in a situation where you don't know your lowest, then there will be a challenge at the end of the day. But like I said, in the grid method, you have to ensure that you get to 1 1. 1 1 is the final way, the first thing you need to do. So ensure that you get to the final one. So we've gone through the multiples method, we've gone through the grid method. The next one we have here is the prime factor method. Prime factor method, and we have the index method. So let's try the prime factor method using 12 and 24. Using 12 and 24. So let's break 12 into, 12 is 4 times 3. Now 12 is 4 times 3. Now, but we know that 4 is not a prime number. So we have to break 4 into 2 places to give us a prime number, which is 2 times 2 times 3. I believe you follow this very well. And the next part, 24. 24 is 8 times 3. And what's 8? 2 times 2 times 2 times 3. So that's 24. So now, under the prime factor method, you will circle the parts that are similar. You will circle these parts, they are similar. Then you circle these parts, they are similar. So you see, we circle these 2, we circle these 2, we circle these 3, but we have this left. So if we are going to find the LCM now, using the prime factor method, we are going to say, oh, the LCM here is 2, because we circle these 2. Then here we circle these 2 here. Then we circle these 2 because this 2 is not added to any other one. And now this 3 that's here, that will circle it. So we have this. So our answer is 2 times 2 times 3 times 2 times 2 times 2 times 3. That's under the prime factor method. Now, in a situation where we now want to apply the index method, this index method now is different. Using the index method, I believe this part is where some persons find it difficult. Let's work this index method using 12 and 24 again. Now, we are going to break this down. Like I said, 12 is 4 times 3, which is 2 square times 3. Now, the next part, we have 24. 24 is 8 times 3, which is 2 raised to power 3 times 3. Now, in the index method, what you are going to do now is to check the number that has the highest power is what we take serious. The number that has the highest power is what gives us our LCM. So, between 2 square and 2 raised to power 3, which one is higher? I believe you know it's 2 raised to power 3. So, meaning that our LCM will be equal to 2 raised to power 3. Because we have 3 here, 1 times 3. So it will give us 2 raised to power 3 times 3. That's what is going to give us our LCM. So our LCM, we have to ensure that we pick the number with the highest power. The number with the highest power gives us our LCM. But in a situation where the number with the highest power, they are repeated so many times, maybe here is 2 raised to power 3, here is 2 raised to power 3. As a good student, you just pick 2 raised to power 3 because 2 raised to power 3 is what we need because it's similar. So in this case, you see 3 here, 3 here, 3 here, 3 here. What are you going to pick? You pick 3. So meaning that whenever you are finding the LCM using the grid method, it must end at 1 to 1. Whenever you are working with the multiples method, you will first of all search for your common multiples. Then when you search for your common multiples, you select the lowest common multiple. That is for the multiples method. And when it comes to the prime factor method, all you have to do is to select where there is similarity. And when you select it, you can now group it 2 times 2 times anything you see. Then another one is the index method. You ensure that you check the one with the highest power. The number with the highest power is where our LCM will come from. Just like this question where we have 2 raised to power 2 times 3 and 2 raised to power 3 times 3. We have that the LCM is 2 raised to power 3 times 3. Are you following? Yes.